And just here, we're going to be careful and just try to make sure we have all of the situation completely narrowed down as best as we can. Everything's in descending order, 5, 4, 3, 2, 1. The thing is we don't have a constant because we have a power of x that we can factor out first. So x times x to the fourth minus 3x cubed minus 9x squared plus 15x plus 20. All of that equals 0. So right away, if I set each part equal to 0, this front one right there is telling me one of my roots. I know for a fact, so let me come over here, x equals 0, that's part of my answer right away. Okay, so now we're going to we're going to look at, just focus on the rest of that part to find the other pieces. So let's list off our potentials. First of all, so x is going to equal plus or minus the factors of 20. It's always the factors of that back number, so I'm going to be careful here. But 1, 2, looks like 4, 5, 10, and 20. We've got lots we can do here. The factors of the front, though, are just 1. So x is going to be plus or minus 1, 2, 4, 5, 10, and 20. So those are all of our potentials that we're going to try when I come over here for synthetic division. Okay, so now when I list out my coefficients, I don't want to go back to this original one. I'm just going to go to the one right here in the parentheses because that's where we're trying to pull from. So the fourth power, the third power, the squared, the first power, and then our constant. Okay, so let's see what we can go with this. I'm going to take a wild shot in the dark, and I'm going to try to keep my numbers small, so I'm going to maybe go with -1. Let's try that. So drop the 1, multiply it in, add it up, multiply it in, add it up, multiply it in, add it up, and looks like, whew, it looks like we are good. That's awesome. Okay, that's going to give us a cubic, and we have for sure one solution. We know for a fact that x equaled -1, okay, because that gave us here in this box. It checked out for us. So what we could do, if we wanted to, is we can keep our fingers crossed. We could try another number, or we can come right here and see what kind of polynomial comes out and see if we can factor that. Who knows? Let's try that though for a second. So that polynomial would be, knocking down a power, would be x cubed minus 4x squared minus 5x plus 20. Well, if there's 4 terms, one way I can check for it is to do factor by grouping. So x squared times x minus 4. If I pull out a 5, that'll also give me an x minus 4. So it looks like this is going to finish up by grouping. Okay, we will get x squared minus 5. And then what was common in that group was x minus 4, or if you wrote the x minus 4 first, and then x squared minus 5. It's the same thing. So finishing this up, it's telling you from this guy that x squared is equal to 5, and from this one, x equals 4. Okay. Well, to finish that left one up, we've got to put the plus or minus when I take the square root of both sides. So that's x is equal to plus or minus the square root of 5. Okay, well, let's add those to our list of potential solutions. So in addition to 0 and -1, we have x equals 4, we have x equals the square root of 5, and x equals the negative square root of 5. Okay, so all of these right here are our potential solutions. There's 5 of them, and our original polynomial had 5. And I want to give you guys a heads up real quick. A thought just came to my mind is when you try a number inside that box, if it works out, don't just take it off the list. Sometimes a number can happen, you know, we have those things called double roots and triple roots. So just because -1 worked out doesn't mean I don't want to try it again. It wouldn't hurt to try it again because you never know. It could have been a double root. Okay. So definitely keep that in mind as we can probably go here to example C. It might be there, I'm not sure though, but let's try that out. So then here we're just kind of going through our normal steps we've done before. It looks like we all in descending order. We're looking for 5 solutions. All those coefficients are positive. I don't have any power of x that I can factor out first. So right away we need to go with our potentials. Okay, so x is going to be plus or minus the factors of -2, which is just 1 and 2, over the factors of the front, which is just 1. Whoa, we do not have a big list at all. So it looks like some of these have got to repeat. So all we're trying out is basically 1, -1, 2, and -2. some of these have to repeat. So let's try this out. The coefficients are 1, 3, 1. Just making sure also that nothing skips. So making sure I don't have to put any zeros in. All right, so what are we going to start with? I don't know. Let's try 2. Let's see. So drop down 1. 1 times 2 is 2. 3 plus 2 is 5. 5 times 2 is 10. 11, 22, 17, 34, 28. You see how huge we're getting here? 56, 54. That's not 0, so that means that definitely did not work out. So 2 is not going to happen here. Okay, so let's think about another number we can possibly try out. How about we go with maybe -1? So if we drop down 1, that'd be -1, and then 2, -2, and then -1, +1, -4, 4, adding those up, -2, multiplying it there is +2, and then we get a 0. So that works out. Okay, there's one of the 5, so we know that x equals -1. Okay, so now what I want to do is I want to start this process again. I don't know, let me come back in blue. So now we're looking at this as my polynomial. So I have now a new box. Here are my coefficients. I'm just trying to at least knock it down to a cubic, because from a cubic at least I can try to factor from there. So what number do we want to try at this point? Well, should we maybe try -1 again just to see if it works out? Let's see. So 1 to -1, adding it up. -1, -2, multiplying it together would be 2. So -2, multiplying it in is +2. Woohoo, it worked again. Okay, so again, if I go back up into my list, then I can say x equals -1, x equals -1 again, and let's see about getting the rest. So let's go here. That looks like, since now we're down to 4 terms, we can probably factor that. I'm sorry, yeah, 4 terms. Okay, this first time instead of division knocked it from a 5th power to a 4th power. The second time knocked it down to a 3rd power. So my coefficient then would be 1x cubed plus 1x squared minus 2x minus 2 equals 0. So let's group the fronts and the backs. So x times x plus 1 minus 2 times x plus 1. Okay, that's looking good. Let's pull off that x plus 1. That's going to leave you with an x minus 2. So from here we get x to be -1, and then from there we get x to be 2. So look, we got x equals -1 3 times, and then x equals 2 once. So you could either write it like that, or you can, if I come down here, let me write it like this. You can say x equals -1, and you can say it's a triple root because it happened 3 times, and then you can say x equals 2 as just a single root. Okay, so definitely something to look forward to, or look towards. And if you went back up in your notes, what it tells us is that if a root ever happens an odd number of times, the graph will definitely cross through it. So at x equals -1, the graph is crossing, and at x equals 2, since 1's an odd number, kind of technically, then you could also consider that crossing straight through as well. Okay. So this is an idea of how to list out the potential roots of a function and finding them using the rational roots theorem.